Hello and welcome to another episode of CISO Tradecraft, the podcast that provides you with the information, knowledge, and wisdom to be a more effective cybersecurity leader. My name is G. Mark Hardy, and today we're going to look at agents, software that we install on just about everything to report back status, configuration, and problems. There's several classes of agents, and as a CISO or a security leader, you should be familiar with all of them. So I hope you enjoyed today's podcast, and as always, please follow us on LinkedIn and make sure you subscribe so you can always get the latest updates. Now let's talk about that term agent. When you first heard of that term, did you think of FBI agents or cybersecurity tools? Even better, have you heard of that term agent in the past? I hope kind of so. On today's show, we're going to discuss what does an agent do, why is it helpful, what are 7 common types of agents you'd expect to find in large IT organizations? And also, if you stick around to the end, we'll talk about secret agents. So let's start with the basics. Managers need to know the status of key projects and employees for an organization, right? The same thing could be said with cyber tools. We want to know the status if things are patched, configured, running, slow, broken, etc. If there's a service or an application, we need to ensure the thing is running smoothly and has high availability. If not, there's probably an IT outage. To address this problem, IT organizations leverage tools to pull information about endpoints, servers, network devices, and applications. Let's say we have 1,000 servers, and we're given the task to make sure that all of them are patched and with the latest security updates from Red Hat. We need to find some way to drive accountability to ensure each of the systems are known and patched. One way we might approach this problem is to perform a remote scan. For example, if we know all of our servers are within a certain IP address range, then we can perform a remote scan. We can think of a network mapping tool like Nmap to run a port scan to identify any IP addresses that are active and services that might be running. Now let's talk about the pros and cons with this approach. On the pro side, this is simple to do, which is important in a big organization. Imagine if you have to get something installed on 1,000 machines. That could take a lot of approvals and developer and admin resources. With a remote scan, that isn't necessary. All I have to do is open up one machine to run an Nmap command, and boom, I can scan the network like an attacker. 2, since I'm running scans like an attacker, I can expect to see the same responses. What IP addresses have systems assigned? Are there any services or ports that are open? Are there any known CVEs that we should worry about? Stuff like that. Well, then what are the cons with remote scanning? Well, they include that your scan is a single point in time. Just because the server doesn't respond doesn't mean it's not there. For example, let's say I have a server that's only available between 8 a.m. and 5 p.m. After that, we turn it off. Now, let's say I perform remote scanning at 6 p.m. to minimize the impacting servers during core business hours. This remote scan will never find the server, which could have some significant vulnerabilities. Another potential con is that the data that the server provides back, perhaps I scan a server and I see it's running Linux. That's somewhat helpful, but depending on the precision of the scanning technique in the tool, it may not tell me if it's running Ubuntu or Red Hat or even which version, and therefore I don't know what proprietary patches need to be put into place. Let's say we're really concerned that we have our servers fully patched, and we don't trust in remote scans. Enter the concept of an agent-based scan. Here we install code on each of our servers, that is to say an agent, that can perform a function and send data back to the server. Let's say our agent does a simple command like list all packages installed on a server. This command collects data and then sends the data back to a centralized command server where the data of our 1,000 servers can be aggregated. Now let's look at the pros of this approach. We get much more detailed information. The detailed information I can receive is limited only by the creativity of my ability to write commands on that server. This is much more helpful than what the server publicly tells everyone. Also, I can choose a cadence when the server talks back to me. For example, every time the server is running, I want it to beacon back to me every 2 hours and give me a situation report on the packages that are installed and running. This minimizes remote scanning systems and probing IP addresses that might be non-existent or even turned off. Well, the cons of this approach: to have an agent-based scan work effectively, you need to have the agent installed on the box. If it's not there, it won't scan. Secondly, you need the agent to actually be running. I know this sounds basic, but if the agent isn't running, it's not sending any data back. Third, if there isn't anything that could be limiting the agent to talk back to the command server, like a firewall, then we'd miss knowing the state of our servers. Another major disadvantage of an agent is they take resources like storage and processing power. While a lot of servers have a lot more resources than they used to, and overhead may not be an issue, this can be a problem when you're installing agents on embedded devices, where you might not have any extra memory with which to work. So that now that we get the basics of agents, how they work, and the trade-offs of running them, let's look at some common agents and you'll probably encounter in the workforce. Number one, endpoint configuration agents. If you're running Windows on your laptops, then you need a tool to configure them appropriately. We really don't want guest user logons on machines that could be left in Ubers and taxis, or allowing the end users to have admin rights with whatever password they decide to put on their account. So a lot of organizations will use tools like Microsoft Endpoint Manager, which is formerly known as Microsoft System Center Configuration, the SCCM. The SCCM manager for driving compliance of patches and preferred configurations. Note there are commercial options for this type of tooling, like Tanium, for those who don't want to use organic Microsoft tools. Number two, mobile device managers. If you were looking for the mobile equivalent of Microsoft Endpoint Manager, you'd see a different category of agents called Mobile Device Management, MDM, or Mobile Application Management, MAM tools. These agents, such as Microsoft Intune or Google Endpoint Management, specify what you can install on your phones, how company data should be protected, what VPNs might be leveraged. Some of them can even give you a remote wipe capability. These type of tools can be important when you receive a U.S. government mandate to remove certain foreign source software from your devices. You can do so from a single console. Number three, vulnerability agents. Now, endpoint and MDM solutions are good for patching operating systems, but they're not good to know if your Java version has lots of vulnerabilities associated with it. To address this problem, organizations usually install tools like Qualys or Nessus, which can identify application-specific vulnerabilities. This is something every security team should implement and permits a more broadly defined vulnerability management program to be effective. For example, you read a threat intelligence report stating a certain vulnerability is being remotely exploited in the wild. A properly configured vulnerability management tool should tell you whether you are vulnerable, and if so, what systems or applications need to be patched. Number four, antivirus agents. Anyone who's worked with a PC for the past 20 years is familiar with the class of software tools known as antivirus, or AV. They stop harmful code from running on your endpoints. This is important because users click on phishing emails, they download things they're not supposed to, they open up websites, and these events can launch harmful attacks, and your AV is the best safeguard you have to stop the software from running or beaconing out of your organization. Antivirus tools and agents do exactly what you think they do. You go ahead and they provide some capability of protection. Now, as most of us know, the concept of a virus relative to other types of malware, such as worms or Trojan horses, really represents a fairly small percentage of what's left. Viruses were popular back in the 1990s, maybe even late 80s, when the first time I remember seeing one of those. But even though we've shifted from tools like viruses that require human interaction to spread, to worms and malware and other types of tools which kind of get by on their own, they haven't renamed the type of software. Besides, would you really want to go ahead and have anti-worm running on you when you could have antivirus? Just sounds a little bit better. Now, it's interesting, although you can buy AV for Chromebooks, Google Chromebooks, by design, Chromebooks are a hardened Linux kernel that restrict applications installation, meaning for the most part, you're just running a dedicated web app and browsing device. Each app runs in its own container, and downloaded .exe files, they just won't execute. Since there's no underlying vulnerable operating system like Windows, it's a lot harder to target for malware writers. However, that hasn't stopped enterprising vendors from marketing Chromebook antivirus products for $30, $40, $45 and up for an annual subscription. Essentially, I think the value is what gets bundled. LifeLock gets bundled with Symantec Norton antivirus for Chromebook. VPN tools get bundled with Bitdefender and Avira, and robust ransomware protection, whatever that means, is also included with some of the tools. All I can say is if you have enterprise Chromebooks, choose wisely. Number 5, endpoint detection and response agents. Antivirus is great at stopping attacks that have been seen before. I'd expect every antivirus to stop even popular classic viruses like My Doom, I Love You, Code Red, SQL Slammer. Bring back some memories. This is low-hanging fruit. However, what happens if someone writes custom malware just for your organization? You're a target. Well, chances are antivirus is going to miss it. Enter Endpoint Detection and Response, or EDR. When AV misses things, EDR collects log events and identifies potentially nefarious patterns. An EDR tool might detect unusual behavior in recently downloaded software that opens up a port to talk back to some remote IP address and appears to be sending large amounts of network traffic. You might want to take a closer look at that because it could be a remote access Trojan. Number 6, data loss prevention agents. Another problem IT organizations have is data sprawl. Essentially, how do we keep sensitive data from going to the wrong places? To do that, organizations put data loss prevention, or DLP, software on their boxes. One simple example of this is, let's say we can classify our Word and PowerPoint documents as unclassified, sensitive, and internal only. By the way, don't use Defense Department classifications, or you'll have some laptop that's labeled top secret and you have donut recipes on there, and some overzealous Marine will tackle you thinking that you're a spy. Okay, so just pick your own terms. You need something that prevents these internal documents from being emailed, Dropboxed, or uploaded to websites outside of your company. So having a tool to watch your endpoints can protect your organization and identify insider attacks. DLP tools, in my opinion, only help with careless or clumsy employees. A skilled attacker would first encrypt or obfuscate the sensitive information before exfiltration and evade these tools. My friend Kevin Fiskus used to give a presentation entitled DLP Fail, whereby he'd demonstrate several techniques such as encoding, steganography, and covert channels to bypass this type of control sets. The reason I mention this is you should not place a lot of trust in any DLP tool if your threat is a knowledgeable attacker. Number 7, privilege access management agents. The last type of agent we're seeing in big organizations is a privilege access management, or PAM tool. Here's why you might need this type of agent. Let's say a developer wants to install an application on a box. Typically, these types of events require admin access. The problem is you don't really want hundreds or thousands of admins on boxes that can turn off all the other security tools on your endpoints. So you need a way to grant a developer a one-time only approval to install software. That's what a privilege tool does. If you haven't heard of a solution like that, then you can look at vendors such as CyberArk and BeyondTrust. They provide these types of services. In addition, PAM tools allow partitioning of the all-or-nothing privileges such as Linux root. Now, Microsoft's come a long way in creating granularity of privilege. A quick look at Azure Control Panel will confirm this. We've learned about remote scanning tools and agents, and we discussed 7 common agents you'll find in the workplace. But is there something else we should know? Now, what about secret agents? There's a new breed of agentless tools coming out, and I'm going to call those secret agents. They're a hybrid of agents and remote scanning. Now, these are tools that you can query cloud APIs from Amazon, Google Cloud, Azure to gather information. To start, you begin by granting these secret agents an audit or read everything role to your cloud environment. This audit type role allows them to query cloud APIs to know how many servers are running, how much RAM they're using, what configurations are in place, etc. These agentless tools often have some write privileges to make backups of your compute environment. This allows them to run security checks and scans on the backups. Thus, there's no agent on the compute instance running, but there is an agent on the backup of the compute instance. This approach is what you see in next-generation vulnerability management tools like Wiz, Orca Security, Kavonix. There are significant pros to this approach. First, agentless approaches know exactly what's running since it's getting data directly from the cloud provider. There isn't an agent blocked by a firewall rule. Second, by not having an agent on each compute instance, this approach saves system resources. Just think, if each agent took 5% of system resources and your organization had 10 different agents per server, that's 50% utilization. This would add significant costs since your entire organization would need to buy additional resources to handle the agent demand. Now, using this approach that we're discussing avoids this entirely. Here you take a snapshot of the compute instance, run the security scan on the snapshot, and then delete it. This approach allows you to minimize your costs while getting full scanning capability. Now, there's some cons as well. This approach is highly dependent on your systems being in the cloud to query cloud providers and to make snapshots or backups. Doesn't work so well if you're still on VMware on-premises solutions because there isn't a cloud API to query. So if your organization isn't 100% cloud, this means you probably need two different solutions if you want to try this. One solution for the cloud and one solution for on-premises. So let's summarize. Agents in general are software tools that report on the state of systems to a central collection point. Agents can be highly specialized, with vendors building tools in verticals such as endpoint configuration, mobile device management, MDM, vulnerability management, antivirus, AV, endpoint detection and response, EDR, data loss protection, DLP, privilege access management, PAM. Agentless tools also work with less overhead, but those probe systems from the outside or observe network behavior, and systems that are down or quiet or firewalled can be missed. Factoring in the overhead of agents should be part of your planning process. You don't want to bog down a device to the point where it loses its utility. Well, thanks again for taking the time to learn about agents. Remember to study them, find out what works in your environment. There's pluses and minuses with each approach, so choose wisely. Thank you again for listening to CISO Tradecraft. This is G. Mark Hardy, your host, and if you found this episode interesting, please share on LinkedIn and with your colleagues at work. Thank you, have a wonderful day, and stay safe.